And welcome back. As we continue looking at comments here in our next lesson, today we're going to focus primarily on how to take those comments and use it to not just write better comments, but our code in general, how we can make it have more purpose and clarity. So the first thing we're going to look at is this naming of constants. Constants, of course, are just what it sounds like, constant values. So when we have variables here, because constants are a type of variable, remember, they should be named appropriately. We're not simply just going to call it like variable X, variable Y, variable Z. Those are technically valid names, but they aren't necessarily going to have as much meaning to us as something like, value of string or something like that, where we can have some sort of value that's going to be reflecting of that. Now, the problem with numbers in a computer program is that if I just have a number by itself, it doesn't necessarily carry significance. If I were to, for example, have pi, and I were to do 3.14, well, that 3.14 by itself doesn't necessarily have any meaning until it's actually used. And so a lot of times when we have values, let's say like pi, we want those to be kind of predefined because they might be something that is never going to be expected to change. We're never expecting pi to change because it's a constant. And so because it's constant, we can see that it is technically predefined. It's never going to update in its value. Now, because we have constants have this special kind of meaning, and to give them that defined meaning we're looking for, we're usually going to initialize our variables to a numeric value. And so, for example, we say like int numeric value equals 10. And you notice this is a little different styling than what we're used to with our variable names. That's because when we're naming constants, all the letters in the variable name are uppercase with an underscore between each word. You'll notice it says numeric underscore value. And again, these are all uppercase. So this is a little different than what we've seen because up to this point, all our variables and stuff have been camel case. So a little different than what we might be used to, but it's just a styling convention that we use to kind of help differentiate a constant from that of a normal variable. Now, we can run into problems with constants. The biggest thing with naming constants, as we might have seen on that previous slide, is we could accidentally change the value of the variable. Even though we've named it as a constant, we could still accidentally overwrite it later in the program. I could say, well, I'm just going to change numeric value to 100 now, and now it's 100. So to avoid an accidental change, we just initialize a constant with the following thing. So we say public static final type name equals a constant. So if we use our value from the previous slide, we would change this to public static final int numeric underscore value equals 10. And you'd see that there's a couple of new terminologies in there that we may not be as familiar with. All right, we're not going to worry about what those all means. We just know that anything that says static final, it has to be placed outside of the main method. So before we see public static final main, we are not going to worry about our constants being inside that because they actually have to exist outside of that. All right, and that's another special little thing about constants. They have to be outside of a program there. Now, here's a quick example code with a constant. Now, again, I'm going to leave this here because I want you to kind of take a look at how this is working. I'm not necessarily going to go through it in our coding example because I'm going to leave it right here for you. So if you need it, come back to this point in the video. You can rewatch it. But in here, you'll see we have a public static final double because it can be more than ints. And it says interest underscore rate equals 2.5. And then in here, we have a very simple interest calculation. Double balance equals 100, comma, interest. So we have a very simple little percent coming in here. And we say that interest is equal to balance times interest rate divided by 100. And then we say on a balance of balance. So that's just doing this right here. You earn interest rate of all in one short year. The important thing I want to kind of show, though, again, is just how we implement this public static final double. All right, so that's how you do a constant. You're not going to necessarily see too many of these in your programming, maybe from the day-to-day, because there are going to be instances when you need one, but a lot of times we will see more regular variables, but this is still one of those things that's really good to kind of know. As we kind of dive deeper into Java, we will look more at indentation and all its kind of special quirks, so to speak. But generally speaking, what you need to know is that for each structure that we nest inside of another structure, we increase our indentation by one indent, or simply pressing tab on your keyboard will do the same trick. Now, the nice thing is, well, when you're working in an IDE such as Eclipse, much of that indentation is automatically done for you. Now, it doesn't mean that it's perfect. Things can still happen, but we can make sure that we are decreasing or increasing accordingly. And, if you ever sit in class with me, I will cover like, yeah, you should go and make this cleaned up, because it does make it visually easier to see where your code's at when you have proper indentation in play. And besides being easy to read, it does actually help when we start looking at debugging our code, trying to find those errors and stuff like that, and seeing which level our program is on, because everything is then properly indented. Now, obviously, if we're talking about structure, how do we go then structuring our program? Now, generally speaking, when we look at structuring our program, we're going to put our variables at the top of our program. All right, this includes any numeric types or string types. They're going to be there pretty much at the very beginning of our main method. Now, because we're starting out programming, it's a good practice to use comments to help explain our code. And we have looked at these before with our last lesson, but here let's add one new comment in to kind of help us start thinking about how these things are being used. So before we put those variables into our program, we're simply just going to add the comment, declaration, and initialization of variables and objects. Now, we haven't talked about objects to this point yet, but it's a good comment to kind of help us start thinking about some of those objects that we're going to end up creating. And we'll actually start doing some of that actually in our next chapter. We're going to actually look at some of those in the next unit of something called the scanner. And so the scanner will actually end up creating objects that we're going to end up start using within our program to add more features and functionality. Now, the last thing I want to kind of touch on here is the best commenting practices. I already talked about some of the things with commenting in our last lesson, but when you start talking about some of these best practices, the thing you have to remember is that commenting every line of code is very impractical, and it fills your program with obvious statements. You probably noticed this a little bit last time when we looked at some of those things. Like, yes, that's exactly what my print line statement is doing. And we said, well, we were kind of starting off, and that's okay. Now, as you get deeper into your programming career, a well-written program includes a lot of times what is known as self-documenting. This means that our comments are not stating the obvious. All right, they're not like, hey, sum equals num1 plus num2. Well, I'm adding the two numbers and stores them in sum. Yes, we know that. We can figure that out if we have a basic understanding of programming. But yeah, again, because we are first starting out right now, we're going to see some of these kind of impractical, obvious comments that we will be very able to quickly start moving away from as we learn more tools. The thing is, right now, we're just kind of more using the comments to kind of learn how to use them, not to necessarily use them in a proper manner. All right. And again, as we mentioned, our programs are very simple, so we're going to write those simple comments for the time being until we get to much more complex structures. And I just want to show a quick example here with some of those things. So I'm not going to go ahead and show a constant in here because, again, I gave you an example of that in the notes. But what I do want to show is adding those comments in here. So in here, you'll see that my string and my integer in this lab that we had done previously are at the very top. And those are one of the things that we had talked about. So they're here at the very top of my program. Now, I do want to add that comment in. Now, when you start doing this, you can go ahead and place that comment in first before you start writing your code, or you can write your code first and then press enter and go ahead and add that comment, which of course, as we mentioned, was the declaration and initialization of variables and objects. And that's true because all these here are technically variables or objects. And then down here, I have my two print statements. All right. So I could say this outputs the concatenation of first string, a space, and second string. And of course, we can add another comment here as well. And this one could output. And we say output the concatenation of operation string and num1. All right, and again, just like before, when I go ahead and run my program, the comments do not show up. However, as a programmer, it does give me some more insight into this.